Okay, good morning, good afternoon, and good evening, depending on where you are in the world. Sorry about the slight delay if you've been waiting. I just had to move my face on the screen because I realised in the preview, I don't know if this was happening on the previous live streams, but I had a big red subscribe button over my face, so hopefully you can see me okay. I'm just checking in the preview, it looks good. And welcome back. If you've seen some of the other live streams this week, it's the same sort of deal. We'll be going through some JavaScript exercises. Bit of a difference in today's stream. We're just going to be creating the tests and the specs and everything from scratch. So we will be looking at how to do that in the repository, and there's a link to the repository in the description here as well, so you can grab a copy of that and actually clone it and take a look at the work that we're doing in here, and obviously play along and kind of code along with the exercises as we're doing them. Okay, so let's just have a look first of all at the exercise for today. So we're still on the original tutorial that we did on this a few years ago now, with the beginner exercises, and we're looking at part one. Just checking the stream health here. I'm getting a bit of a notification up here in the YouTube studio. It seems okay. If you can give me a shout out maybe in the chat if everything's working okay. It'd be a bit bad to do a whole live stream and no one be able to see it, but yeah, that would be appreciated. So yeah, going back to the exercises and tutorial. So we're on exercise 3 now. And this exercise was all about writing a JavaScript program or function to replace every character in a string with the character following it in the alphabet. And looking back on the tutorial, it wasn't quite a complete solution, because what we should do is when we hit a Z character in the string, we should obviously go to the start of the alphabet and actually replace that with an A. And what I think we'll do in this tutorial as well is make this function a little bit more flexible as well. So you might want to move 2 characters in the alphabet or 3 characters, and this is quite a common thing if you're doing things like really simple ciphers like the ROT13, rotary 13 encryption, and you just want to move a character a certain amount along in the alphabet. So that's the aim of the exercise, at least today. So going back to our repository, as you'll see, we haven't got the exercise file set up, so that's what we're going to really focus on today, how to set the tests up, and then we'll provide the solution. And we are going to create the tests first, so we're doing it in a kind of test-driven development way. So this is kind of, if you were doing proper software development, you would kind of ideally try and write the tests first to describe the function or the code that you're writing, and then actually write the solution to that afterwards. So we're going to take the same approach in the tutorial. Okay, so let's get cracking. And thank you very much, Mohammed, for letting me know it's working. I'm not talking to myself, that's good. Okay, so let's create a new file in our tests folder. So exercise 03 spec.js, and just a note as well, the jest test runner does need to have spec in the file name for it to find it, at least with a setup that we've got. And obviously we need a corresponding source file as well, so we'll say exercise 03.js. And just for completeness as well, in our package.json, we've got some scripts to actually run the tests. So I'm going to copy one here for exercise 2. I'm just going to change that to exercise 3. So now if we say npm run, and then we're going to run obviously exercise 03. So that's just running this npm script here, and then we'll pass in -- watch. And as mentioned yesterday, just a little bit of a kind of hack to get this running, just that one file, is to just go into the, sorry if I did that a bit quickly, but if you go into the filter by a test name, regex pattern, and we're filtering by the file name, and then just hit enter, we'll be in a watch mode now, so these tests, the tests will rerun every time we make some changes. And of course you can see it's failing at the moment because Jest is telling us that we haven't got any tests set up, so that's all good. Okay. So the first thing I'm going to do just before I actually create the test file and write the tests is I'm just going to put some boilerplate or a placeholder for the exercise for the function that we're going to be creating, and that's simply because we need something to import into the test file to actually run. So we're just going to set up a boilerplate, a default function that we can export from here, so we've got something to import into the jest file. Okay, so let's create a function. And in the original tutorial, it wasn't important, but I gave the function the name of move-chars forward. So I'm quite a big fan nowadays of actually creating a really long and descriptive function name or variable name, if that's what we're working with. So I'm going to say move-chars forward in alphabet. Okay, so it's just really explicit as to what we're actually doing with this function. It's quite a lengthy function name, but that's okay. We can just, it gives us a bit more explanation as to what this function is intended to do. Okay, so once we've done that, we can just export it, and the way this repository and package is set up is we can use the ES6 module syntax here, so we can then just import that into the jest file from here, and just making sure we're grabbing that from the source file, and the correct one, which is exercise 3. Okay, so far so good. So we still haven't created any tests, so let's get started writing some tests for this particular function. And notice we're doing this before we've even written any code to actually solve the problem. Okay, so I'm just going to set up a describe block. So we could break this down into different sections. So a describe block is basically just a section of tests or a suite of tests, but we're not going to be writing that many for this particular function because it's not that complicated. So we should be okay to just have all of our tests in this one describe block here. And you may have come across before that there are sort of setup and teardown functions that you can run as well. So before each of the tests that we're going to write in a moment are going to run, you can run some other code, but there isn't really any need to do anything with this at the moment. So we'll just kind of crack on and just remove that before each block there. But if we were doing something like had a class and we needed to create the class from scratch, then we could obviously add that in there as well. Okay, so let's write our first test in our spec file with jest. Okay, so the function we're going to be creating is move-chars forward. So we'd expect if we passed in like the letter A, for example, that we would get the letter B come back. So let's say we'll give it quite a descriptive name. So we'll say it should return B if we pass in the character A. I should say should return the character B if we pass in the character A. So very descriptive as to what we should be expecting to see. And then we can actually use the function that we've imported to kind of get the result and see if it's as we expected. And you can save this into an intermediary variable like result or something like that if you like. But there isn't really any need to, because we're just not going to be reusing it in any part of the test, but it can be handy sometimes if you're writing several assertions to say whether or not the result is as expected. Okay, so we'd have something like this. So if we move chars forward in the alphabet and we pass in A, we would expect the result, and if you just put a period at the end of the expect function here, you can see here in VS Code we've got all of the different matching assertions that jest provides, and there's loads of different things in there, but all we need to say is it should be the letter B. And if we run that, if we save the spec file, the test runs, and you can see it's failing because we're expecting the code there to be we're expecting the result as we've put in this expect block here to be B, but it comes back as undefined, and the reason for that is because we haven't written any code in that function yet. Okay, so that's a basic test. We've got a couple of things here. We could actually put in some different expect values in here as well. If I just take that out in here, actually no, we shouldn't do that because we've said explicitly in the it statement that if we pass in the character A, we should get the character B back. So we'll just leave that one as it is for the moment. Okay, so that one's quite explicit, but what we could do is just copy that test, and we should and say something like it should return the character, the next character in the alphabet. Let me just leave it as that. So should return the next character in the alphabet. So that is what we would expect. So we can just, instead of having this intermediate result variable there, let's just do that exactly the same as before. So we know that already works. So we could just say B and C. And let's do D and E. And E and F. So you can see when we run that, we've got another test down here, and it actually fails at the first one, so it doesn't run these extra expect statements here, simply because the first one fails, so it doesn't bother checking any of the other ones there. So, but if we were to write some code in there, we'd find that if this first one passed, then the next ones would be checked, and hopefully they would all pass as well. Okay, so that's just a couple of tests. Now what we could do at this point is write some code to actually satisfy those tests. So we could go into our exercise source file here, and we're going to be passing in a string as an argument here. And then you may have seen in the original tutorial we did something like this. We said get the string or create a new string from char code, and then this will actually generate a new character from a number, from the ASCII value that's passed in, or from the char code value that's passed in. So we could then just say the string dot get char code at 0, and then just +1 onto that. And if we just have a look at that, oh, it's not get char code, is it? It's just char code at. And you can see now if we run that, we're actually getting the right results back, and those two tests are passing. So we could do something like that. We could write our minimum bit of code in there just to get those tests to pass. But then we're going to find another problem when we write our next test, which I'll show you. Okay, so it's not massively explicit from the kind of exercise that we're working on, but it should return all the characters in the string moved forward in the alphabet. Okay. So we can describe that quite well with a test here. So we can say if we pass in to the function something like ABCD, we should expect the result to be BCDE. So you would have thought that would work with the code that we've already provided, but of course the code that we've written so far only is actually returning the first character, or is only looking, it's assuming there's only one character that's being passed in, and also it's not checking the other characters in the string. So it did kind of work, but just didn't do the rest of the string. So we need to go back now and update our our source code, and this is kind of a good way to do it if you are developing a function in an app or something that you're working on, is to write a little test with what you would expect to happen, and then go to your source code and then update it so it reflects the test that you've just written. So basically this test we've just written is to say we want to handle multiple characters in the string. Okay. So instead of just returning the string from the char code at the first point in the string, we just need to map this string into an array and then basically do the same sort of process for each character that's in the string. So let's say string.split, that will give us an array. And then for each of those, we'll say map. And we'll just say each character in that array is going to be the char, and just replace that with that. Oops. of course, that's working now, so it's mapping and doing all of the different characters that are in the string, but we need to join them back together because we don't want an array, we want a string. So that looks good. I'll just say join. Oops. Need to join with an empty string just to get it back into a string. And now you can see that new test that we've written has now passed with the updated code that we've got. Okay, so as I say, it's quite a good way to do it, is to kind of go and write a few basic tests with the expectation of what you would like to happen with the function, and then you can go to the function and just tweak it and play around with the code. And of course we could refactor this into a different way if we wanted to as well, and keep going with that, and all the time you can run the tests and know that the code that you've got in your source file is actually meeting the criteria. But of course, it's only as good as the tests that you've written. So, for example, we might want to pass in, or we might accidentally pass in empty strings or null or faulty values into this function. And of course, that will cause a problem because split won't be available if we've got the string argument is passed in as null. So let's write a test for that. So it should return, let's just say an empty string if the argument passed to the function is falsy. Oops, or falsy. Okay, so the expect statement would look something like this. We'll call the function and just pass in null, and we'd expect that to be an empty string. Should fail for us, which it does. And same sort of thing as well if we pass in undefined. Okay, so these tests are obviously failing now, but the function would have kind of failed if we were using it within an application somewhere along the lines, because we hadn't written tests for these particular instances. So you need to always think about how the function might be used, whether the data that's passed into it could be what's not expected, and how to deal with that when that type of data is passed in. Okay, so back in our source file, that's pretty simple to kind of make these tests pass. We'll just say if not string, then return the empty string that the tests are expecting. And now again we've got it to be all good and passing all those tests. Okay. Yeah, so we were asking about the in the chat there about Z. You're absolutely right, and this is something in the original tutorial. I think I got to the end of it and thought, yeah, this works okay for that particular example, but what about if the character is at the end of the alphabet? And I'll get onto that in just 1 second, but there's just one other thing that I wanted to mention before we look at that. But thank you for reminding me, because I probably would have forgotten about that. What about if we want to make this function more flexible by actually passing in a second argument to say how many characters in the alphabet we're actually going to move across? So for example, if we say if string, we could say something like number of positions, something like that. I'm not sure if that makes sense, but so we could have a second argument that's passed into this, and then that could be added on to the char code to move us forward in the alphabet. So making this function a bit more flexible and a bit more reusable if we needed to push the characters by a different amount. But if we do that, we haven't actually changed our test, but it has actually made all of the tests fail. And the reason for that is in our tests, we're not actually passing in that second argument. So essentially, this would be undefined. So it would always pass in undefined as that function, and this would kind of not move the characters by the desired amount. So we could go in and update the spec files to actually use the additional argument and pass that in here. So we could say we only want to move it by 1 position, for example. But that would obviously mean going through and changing all of our spec files as well. So what we could do instead is just say the default for number of positions is equal to 1. And then now we don't have to mess with our spec file. It's all the tests are exactly the same, but obviously we have catered for being able to push the letters in the alphabet by a different number of positions there. So we should probably write a test for that as well to take into account for it. So we could say it should return, say, letters in the alphabet moved by a different number of positions. Oops, just open that up properly there. Okay, so let's just grab one of these examples here. Okay, so if we pass in A and we move it by 2 positions, it should obviously be C. You can see that's passing as well. And maybe we could do a second one there as well. A, B, C. And it will be C, and then B, C, D, and then C, D, E. And there you go. So we've got another test to actually cater for that additional parameter that we've passed in to the function to make the function more flexible. And now we've got some tests to make sure that it's still passing, even if we do pass in a different value to that. Okay, so yeah, to answer the questions in the... Sorry, Martin was saying the volume's a bit low. I'm not sure what I can do about that at this point, but thank you for pointing it out. So I'll just try and boost that a little bit there for you. Okay, so yeah, there's one final kind of position, or one final test that we need to write really, which is for passing in something like a Z character and then trying to move that to the next position in the alphabet, which should obviously be A if we're moving it by 1 position. So let's write a test for that. Notice how I'm writing the test first and not going straight to the code to actually solve it. So it should return A when the character A, when the character Z is passed in. Okay, so we'll write the test first. So we'll call the function with the letter Z. So we should expect that to be A, using that default position of 1. Okay, so we should have letter A there. And of course that should fail, because what we should get is the curly brace, because that's the next character that's generated from whatever the number is when you add an additional 1 to Z. Okay, so what we could do is in this mapping function, it's nice and neat at the moment, but we should really tidy it up in terms of catering for edge cases like this. So what we need to do is just check if the char code at plus the number of positions, of course, exceeds the limit for whatever position Z is at, then we'll just subtract that and sort of take us back to the start of the alphabet. So it might be handy just to get a dev console up here for the moment, just to kind of play around with those values, because I can't remember off the top of my head exactly what the numbers are. So let's say we've got the letter A and we want to say the char code at position 0, so it's 97. So if it goes to Z is 122, and if we say the curly brace is obviously 123, so that's what's happening in our code at the moment. We're going to this next 123 value and we're getting the curly brace come back. So what we should say is if we hit 122 or a number above 122, then we should subtract that from the kind of char code that we're generating. Okay, so instead of having a nice implicit return here in the map function, we should probably return something like this. And let's first of all get this position and store it in a variable, so just be handy to say that. So we'll say position char code to move to, okay, is going to be the same as this. And if we just use that at the moment, then obviously it would give us the same result, so that's no good. So we could say do a little ternary operator here maybe. So if the char code to move to is bigger than 122, then we'll return the char code to move to subtracted, or we'll remove 122 from the value. But if not, we'll return the char code to move to. Okay, and that didn't work. So there's obviously something wrong there. So it should return the character when the let's just log that out to the console here. So we're getting 1, 2, 3 there, and that's 4. And what was the char there? Let's just make sure we're looking at the right one. Yeah, so Z1, 2, 3. It's saying. Oh, because we've added that. Yeah, so that should be okay. I wonder why it's not returning that then there. So char code to move to is bigger than 122. Let's just store that into a variable so we can see what's going on there. So we'll say new char code. So let's just log that out instead. Okay, so maybe it's just having the ternary operator in the function, maybe, I'm not sure. Is it because... Let's just log this out as well. Ah, do you know what? It's that's we're going too far back essentially. So we need to go back to A. So yeah, it should be 26, shouldn't it? That's a silly mistake. So instead of going right, whatever char code is at position 1. Yeah, thank you very much. Yeah, I saw it in the comment now. So yeah, we should be going back 26, not. Oh no, keep that the same, and then take 26. So yeah, there we go. There we go, silly mistake. But yeah, essentially what we're doing now, instead of just mapping each character blindly and moving it forward in the sort of ASCII table, we're getting the char code position, the new position, generating the code from it, and obviously going back 26 places from the alphabet, generating the new code and returning that. And as you can see, all the tests are now passing, including that one where we're going back to the... Going back to the character for Z, we're going back to the first position in the alphabet, which is A. Okay, so I can't think of anything else really in the function which might crop up. I think if we were using this in anger in an actual program somewhere, we might think of some more edge cases where we want to make this a bit more bulletproof. But I think it's pretty good at the moment. We've got the 6 tests running there for the moment, and it pretty much does everything that we'd expect it to do. And so we've got those tests in place, and if we did want to make any more changes to the function later on down the line, we know those tests, we can always run those tests again and just double check if the changes that we've made to the function are actually still making the tests pass and haven't broken anything else in terms of the functionality of the function. Okay, so that is exercise 3. What we'll do tomorrow, I think we'll do something similar if we get a chance for another live stream. But hopefully you've enjoyed this one and seen how we can write our tests first to describe how a function should act in a particular way. And what I'll do is I'll just tidy this up after the live stream and push this up. So if you do want to down or clone the repository and have a go at these as well, you can do that. And as I said, the link for the repository is in the description as well. But that's it for today. Thanks very much for watching. If you've got any feedback, comments, love to hear them. But otherwise, thanks for that and have a great day.